Part 1. Summary and Review. Summary. Kathryn Miles' Quakeland, On the Road to America's Next Devastating Earthquake, is a popular science book about earthquake science. It focuses on earthquake dangers in the United States and how to prepare for and reduce harm from quakes. As of 2017, the United States has not had a major earthquake since 1989, and between 1967 and 2017, earthquakes killed only 150 people. However, earthquakes are a serious potential danger, in part because so little is known about them. Because earthquakes are unpredictable, seismologists are rarely able to set up equipment to study them in real time. Earthquakes are difficult to prepare for, since no one is sure when and where they will strike. The science of earthquake prediction remains very weak. Scientists do know that quakes are likely near faults, cracks in the earth that allow movement. But mapping faults is difficult, and there are undoubtedly many faults in the United States of which geologists are unaware. The outer layer of the earth is called the crust. It is divided into large plates, which can move. Beneath the crust is the mantle, which is partly solid and partly liquid. Temperatures in the mantle vary widely, and solid rock rises and falls within it. This causes the movement of the crust. It is also responsible for earthquakes. At places where quakes meet, they can form a subduction zone, where one plate is driven under the other. They can also crash into each other. Finally, they can form a transform margin, where two plates slide past one another. A famous transform fault is the San Andreas Fault. Scientists believe the friction caused by the San Andreas Fault is more than 99% likely to lead to an M6.7 quake or larger in California by 2047. Earthquakes are measured by magnitude, or M. The scale is designed so that an M5 quake is 10 times stronger than an M4 quake. A 6.0 quake releases as much energy as the bomb that dropped on Hiroshima. The place where an earthquake occurs underground is the hypocenter. The place directly above the hypocenter on the surface of the Earth is the epicenter. An earthquake is at greatest intensity at the epicenter. Shallow hypocenters are more dangerous than deeper ones. When a quake occurs, it sends out a P wave, which is a vibration of the ground back and forth in the direction of travel. A second wave, the S wave, follows, which moves perpendicular to the direction of travel. The S wave does more damage, but the P wave travels faster. Sometimes the P wave can give people a brief warning of what is coming before the S wave hits. Earthquake applications are being developed to activate when a P wave is detected, giving people some seconds to find shelter before the worst of the quake arrives. Earthquakes pose a serious danger to dams. A damaged dam could release massive amounts of water, flooding communities and cities so quickly that people would have no time to escape. The Hoover Dam is in a good position to survive even large quakes, since it was massively overbuilt. But of America's 84,000 dams, the American Society of Civil Engineers rates around 4,000 as deficient. Many of these dams are privately owned, and some are in states without strong safety regulations. Many dams also lack emergency plans in case they fail. Scientists believe, for example, that the Anderson Dam near Silicon Valley would fail if an earthquake occurred at a nearby fault. After dam failure, a wave of water more than 30 feet high would destroy a nearby town. One of the most dangerous potential earthquake zones in the United States is the New Madrid Fault Zone, stretching from Missouri to the southwest.